Ladies and gentlemen, Madam Director General, dear Martin, Mr. President of the Scientific Council, Mr. Chairman of the Board of Directors, Mr. High Representative of Belgium for Space Policy, Chair, colleagues and friends, it's a pleasure and an honor for me to be present among you in this distinguished place dedicated to science to celebrate this 50th anniversary of the Belgian Institute for Space Aeronomy. Being in function since this summer, I must admit I'm too inexperienced in this fascinating research area to faithfully describe its long history, which other speakers and participants will explain far better this afternoon. Therefore, I will limit myself to give you an overview and summarize in my speech the Belgian support to the space aeronomy and the close cooperation between the Belgian Institute for Space Aeronomy, I'll refer to you as BISA in the rest of my speech, and the Belgian Federal Science Policy Office, or the BELSPO, during the last 25 years. This collaboration has been built during all these years on the generic financial means of BISA, among others its dotation and more recently also its participation in the Solar Terrestrial Center of Excellence on one hand, and on the other hand, programs of BELSPO, such as the Research Actions for Federal Scientific Institution and Science for a Sustainable Development, which are recently have been merged in the current BRAIN program, as well as the programs of the European Space Agency to which BELSPO contributes, such as PRODEX and GSTP. I will highlight some success stories of this fruitful collaboration, and I will try to cover all the activities which are taking place in the Institute. Other of the success stories will be highlighted by the other speakers this afternoon and the members of BISA. I will start at the terrestrial level and progressively move from Earth further into space. Since the 90s, BISA has been involved in ground-based measurements of the atmospheric composition of the Earth through its participation to the Network for Detection of Atmospheric Composition Change, better known as the NDAC, and to the Total Carbon Column Observing Network, better known as TCOM. Unknown to most people, these measurements have moreover been essential for the calibration and validation of numerous satellites. This permanent monitoring continues today at international level and in close collaboration with Belgian institutes and universities, such as the Royal Meteorological Institute of Belgium and the University of Liège. In orbit around the Earth, the BISA has been successfully involved in the development and the data exploitation of several nadir scanning, ultraviolet and visible spectrometers, starting with GOME on the ARS-2 mission launched by ESA in 1995, the Schiamaci on Envisat launched by ESA in 2002, and OMI on the AURA mission launched by NASA in 2004. GOME-2 is now a recurrent instrument on the three successive METOP meteorological satellites of EUMETSAT, with launch in 2006, 2012, and the next one foreseen in 2017. Moreover, the Institute is now leader of the development of algorithms of several products of the TROPOMI instrument to be launched by ESA on the Sentinel-5 precursor mission. In the field of limb remote sensing and occultation in the ultraviolet and visible, BISA was involved in the AURA instrument on the European carrier Eureka, put in orbit by the American shuttle in 1992. In 2002, the GOMES instrument has been launched on Envisat. Also and currently, BISA is a pioneer by promoting small missions in this area, through the full development of the Altius instrument to be launched on a Belgian Proba platform and of the Picasso instrument to be launched on a CubeSat. The BISA also has a long tradition or history in the field of solar spectral irradiance. The SolSpec instrument was already part of the Spacelab mission and later on the Atlas I setup of scientific instruments launched with the Space Shuttle in 1992, a mission well known for the first Belgian astronaut, Dirk Friemuth. An improved version of SolSpec is currently circling the Earth on an external platform of the European Laboratory Columbus, attached to the International Space Station, visited twice by our second Belgian astronaut, Frank de Win. The cluster mission of ESA consists of 4 identical satellites that study the Earth magnetosphere and nearby solar winds since their launch in 2000. The Institute has been contributing to the analysis of data ever since. Let's now move from the Earth orbit to the Mars orbit, where the BISA has been studying since 2003 the atmosphere of the red planet with the SPICAM light instrument on board of the ESA mission Mars Express. Through its contribution to the similar SPICAF instrument on the ESA mission Venus Express, the BISA is studying the atmosphere of Venus since 2006. Based on their involvement in these two missions, BISA is now the leader of NOMAD, one of the most ambitious scientific instruments ever developed with the financial support of Belspo. NOMAD should start its journey to the Mars orbit on board of the ESA mission ExoMars in 2016 to study the atmosphere of the red planet. The broad coverage of NOMAD, infrared, ultraviolet and visible, will indeed enable to detect the components of the Martian atmosphere, even in low concentrations, and to map their locations. Further away at 500 million kilometers, the Rosina instrument is a combination of mass spectrometers and the pressure sensor developed by the BISA at the end of the 90s and currently on board of the Rosetta, in orbit around the well-known planet with a rather difficult name to pronounce, so I will skip the name of that one. Rosina works perfectly after its 10 years long journey through space. We all have witnessed that recently, and is currently analyzing the composition of the comet tail in search of elements and components of life. I'm deeply impressed by these long and challenging spatial research and realizations performed by successive generations of researchers of the Belgian Institute for Space Aeronomy, and I would dare to compare them with the determination of the medieval masons and builders of cathedrals, but with one major difference. BISA constructs scientific monuments in space. Therefore, I hope that future generations will have the pleasure to celebrate, not soon, but in the due moment, 100 years of the Belgian Royal Institute for Space Aeronomy, built on the creda of the BISA determination, innovation and endeavor, which leads to success. To conclude, I would like to congratulate the Director General and all the staff of BISA on their successful journey and achievements, and with this I would like to thank you for your attention.